little bit about my background. If you guys haven't met me before, Tim Titus, Chief Technical Officer and also founder of PathSolutions. My background is I've been a network engineer for over 30 years. So if any of you want to talk about coax, ArcNet, or Novell NetWare, perfectly happy to sit down and share a beer and talk about that stuff. One of the things I realized over my tenure is that troubleshooting is the hardest part of running a network. Typically, you'll have a user come up to you and say, hey, everything's fine now, but 30 minutes ago, the network glitched and I dropped a phone call. What happened? And so trying to solve those sorts of problems is really what makes it difficult. And this is where a lot of folks get stuck because they don't have tools that can really help them. Really, there's a lot of solutions out there that give you some visibility and some monitoring, but it's the troubleshooting that's the hard part, because you never want to be caught unaware on a network, having somebody say, well, do you know what's going on here? And you're the expert. You really do need to know what's going on to be able to solve these problems. So I'm going to go through what we're able to do for folks. And really the core of our solution focuses on three primary areas: network operations improvement, telecom operations improvement, and also security operations. And I'm going to be breezing through these pretty quick of these three primary bases that we cover. Then I'm going to go into a little bit of some of the roadmap of some of the things that are coming up really soon. So this is going to be pretty fast moving, but I figure this is a crowd that tends to be pretty fast moving as well. So shouldn't be any problem keeping up. So starting out, what tends to be missing in an environment is that you have monitoring software, but the monitoring software doesn't help you with the glitches, the hiccups, the gremlins, and the issues that will occur throughout the infrastructure. You could have even a duplex mismatch, and your monitoring software won't be aware of it. Packets dropped out of a high priority queue, spanning tree topology reset, cabling faults. All of these things will happen in the average network, yet sadly, every single one of these is a manual troubleshoot where you have to log into switches, log into routers, check interfaces, check error counters to try and solve. That just means you can't get the problem solved quickly or efficiently, and your monitoring software isn't helping you solve it. What we decided to do is build a solution that deploys on a single server in your infrastructure. What it's going to do that's different than your monitoring software is we're going to go out using SNMP to collect information from every switch and router, just like other monitoring solutions, except we're going to go broad. We're going to cover every interface on the entire infrastructure. So we know where everything's plugged in, and we know what's going on at every one of those connections. Additionally, we're going to go deep and collect 19 error counters of information, all the configuration, all the QoS, and all the performance on every one of these interfaces. That way, we can analyze that information and say, hey, did you realize that you've got a cabling fault here? So that's what plain English heuristics can do. So how we're different is we're going deep with all of those error counters, all the QoS, all the configuration, all the performance on every one of those interfaces. Bring that information back, analyze it with a heuristics engine to give you plain English prescriptions so that you can start being proactive and say, wow, didn't realize I had a cabling fault over in this location. You go take a look at it and realize, yeah, you've got some pinched Cat5 cable that should have been replaced ages ago. Or you find out that you've curved the fiber a little bit too tight 5 minutes ago when you were in the cabling closet, and you get an alert that you're having cabling issues. You go back, relax that fiber, and get the problem solved quickly. Additionally, because we're collecting far more information, more depth and breadth of information than any other product, we can predict things that are going to happen in your network. So this is what we can do for the network operations team. Now, the telecom team, they have a different use case. If they say they have users that say, gee, it's 5 p.m., I know you're packing your bag to leave, but we had a call quality problem around 2:30. Can you solve that before you go home today? Most telecom people would be very unhappy figuring it's going to be a very late night to try and solve it, and you might not even solve it. What we can do is we can chain together and create a path map showing every layer 1 link, layer 2 switch, layer 3 router used between any two IP addresses and show you the history of what happened along that path. The history has enough depth of knowledge of error counters and information so that we can tell you, oh, around 2:30, along this path, you were dropping packets out of the high priority queue, and a few minutes later, dropping packets due to a cabling fault. You can look up at that user and say, oh, that happened because of the cabling fault. I'll get a new patch cord out to that far end station, and I'm going to adjust the QoS queue depth on that queue on our WAN router, thus solving the root cause of the problem because you know what happened along the path. Additionally, for telecom, we have a call simulator so you can simulate voice traffic from any location to any other location with an unlimited number of licenses. So if you have 20 remote offices or 200 folks that need to use it, you have a lot of flexibility. We also do SIP trunk monitoring and troubleshooting. We'll tell you an inventory of where your phones are plugged in and trigger alerts if people move phones, and monitor all of your PoE. For security, we're able to do SOAR. Now, in one sense, there's a problem around SOAR is that you have a SIM or an IDS saying, hey, we found suspicious activity on this IP address. Go research it. And you go say, okay, I'm going to have to crack open the runbook. It's going to take 30 minutes with 7 different tools to try and research what's going on here. In our case, you can use one tool, and we're going to tell you, by the way, here's where that's plugged into your network. It's connected to the Finance 2 switch, interface 12, VLAN 110. Oh, and that's a Dell computer, and it's running Windows 10. Okay, we're going to tell you who's logged in. We're going to tell you what their rights and capabilities are. We're going to tell you what processes are running on that box. And we're also going to tell you who it's communicating with and how. And we'll tell you about the risks associated with that communication. Now, within 60 seconds, you have all of this information in front of you, and you're going to be able to render a decision to say, yes, quarantine this, get this off the network, because this is enough indications of compromise to say, this is some bad stuff happening here. So instead of having that 30-minute runbook, it's now down to a 1-minute execution so that you can follow up on every suspicious activity and know what's going on. Additionally, we have the ability to do vulnerability detection. We're synchronizing with NIST to determine what the operating system vulnerabilities are on every one of your switches, routers, and gateways, and you don't have to do lengthy scans or fingerprinting to determine this. We also have security communication policy monitoring. If you set up a policy so an IoT sensor can only talk to its controller server, that's fine. If it talks to anyone else, I want to know about it. 3 months later, this communication starts occurring. It's going to immediately trigger a policy violation alert so that you can act on that and shut it down. So we also have geographic risk awareness, exposure reporting of bad practices, rogue device detection, and all of your IoT devices are monitored for where they are and who they talk to. Rounding out the solution, we have an automatic network diagram, event correlation, configuration management and backups of all the configurations on your devices, visibility to cloud services, inventory, IPAM, and because folks just don't have weeks to be able to deploy monitoring and troubleshooting solutions, we are rapidly deployed, meaning typically 12 minutes in most environments. That doesn't mean 12 minutes to installation. That means 12 minutes to full deployment. And at that point, you're receiving alerts on bad things that are going on, and you're able to start troubleshooting the network and saying, gee, I didn't realize that we're dropping a whole bunch of jumbo frames on this interface that's misconfigured with an improper MTU. So you start solving problems within minutes. The reason we can do this is the amount of automation we've built into the solution. This is not the type of solution where you're saying set up monitoring of this interface, set up monitoring of this OID, set up monitoring of this device. It's one step of set up monitoring and troubleshooting for the entire network. That means that by minute 13, you're going to be able to start solving problems. So I'm going to go into a little bit of our roadmap. What we have coming down the pike very soon is in our version 12 release is we're adding server monitoring. This is effectively unlimited licensing. Now, a lot of folks end up saying, gee, server monitoring, yeah, that's been done to death. What we've done with this is we've completely automated it. Any server that is inside of your Active Directory domain, we are going to automatically monitor CPU, RAM, disk services, processes, everything you need to know, so that if that's a server in your domain, it's automatically monitored. So you have no maintenance, no management you have to deal with. If you have a server that you don't want to monitor, you can put it on an exclusion list. But the trick here is that if you're commissioning new servers left and right, you don't have to end up changing your monitoring system. We will automatically monitor that and generate alerts. Client computer management, being able to understand where are your client computers, who do they talk to, what are they, and have that full understanding is also going to be included. SNMP trap receiver with alerting. We have this built into the solution. And work from home remote user troubleshooting with remote view. This is a big feature that a lot of folks are demanding right now, because they have users that are saying, gee, when you have a user at home and they have this mystery brand of firewall, you have no idea about the wireless, no idea about their ISP, but you kind of have to help them out, because without your help, they're stuck with nothing. And so whether you're mandated to help them out or you want to be useful to help them out and you're trying to keep the business operating, it's really, you need some visibility to be able to say, hey, here's where the problem is, here's what's going on, and here's what you should do to solve it. And that's what this solution brings. Lastly, if this problem can't be solved through our remote view, we've partnered with NetAlly. And if you guys are familiar, Fluke Networks ended up selling to NetScout. NetScout spun out NetAlly. So NetAlly are those really cool handheld units that can troubleshoot at a really deep level. So we decided we're going to advance our partnership with NetAlly to have some great integration there to be able to feed data to and pick up data from NetAlly's testers. So all of these features are coming November 2nd. Generally, tad over a month, couple days over a month from now, we're going to be sending this out to our folks. Now, I want to go through what remote view is capable of doing. So let's do a short demo of that. So with remote view, you have the internet component. Let's say you have a Zoom team cloud service that a lot of folks connect to. You have your headquarters environment with its firewall and servers. Now you have your home environment. Now, this home environment, you have a mystery firewall, mystery access point, no idea about what's going on there. And what we figure is need to provide some insight into what's going on so that when users have problems, you can help them out. So what we figure is we're going to identify all of the mysteries that can happen. For example, you have a CPU spike and a laptop, or low RAM situation, low memory situation, signal strength problems with the access point. Maybe you have a 10 meg link going on in your LAN, cabling issues, firewalls that are just running red hot because they've got two kids doing Google Classrooms at the same time you're doing business meetings and there's a VoIP phone call going on. These things just can't keep up. ISPs with overloaded links or backbones. Problems with overloaded links at the headquarters and VPN tunnels that are overloading your firewalls. Maybe you have dynamic split tunneling not working properly. So having a single tool that you can run on that laptop and be able to do a test and still have all of that information come back and be saved on that TotalView server, so that you as a network engineer can say, I'm going to give you a tool. I want you to run this. It's going to batch together every one of these tests, bring that information back and analyze it so that I can get the problem solved and say, okay, yeah, I can see what the problem is. It's that your wireless is really low signal strength. Can you move closer to the access point? Or let's have you plug into Ethernet and thus solve the problem. So we're very close to having this released, and this is going to be available on November 1st or 2nd, I think it was. So that's a summary overview of our capabilities and what we're having very shortly coming down the pike. We're really excited about this because we figure it's going to help a lot of folks solve problems either inside their network or for those work at home users.
Hey, Tim, this is all great. How are you actually gathering all that data? Are you putting agents everywhere, or are you putting other things in the network?
Yeah, nobody likes agents. So no, we're not putting agents all over the place. We're using SNMP, we're using NetFlow, we have a patented method of encapsulating ping with G711 and other VoIP codecs and video codecs, so we can end up doing proper load testing. So effectively what we're using is standardized methods the way an engineer would want them used. It's not to the point where we have to tell you, gee, deploy this server at your customer location or at your work at home location and then set up NetFlow. It's like you don't have that at the home. So at the home, what we have is we have there is one agent that gets deployed at the user's machine, but it's not really an agent because it's a single executable. It's going to run its tests. It doesn't need access to anything other than it's going to send out properly formatted G711 ping packets, also WebRTC. So we're doing it so it's minimalistic and easy for an administrator to say, go run this, get me and the results will automatically come back to me so that I don't need to, say, do a remote desktop to try and troubleshoot. It's just really run a tool, press the button.
Nice, thank you.
Okay. Any other questions before we switch into the demo?
What type of, paint me a picture of what your typical customer looks like. Is this something that is enterprise space typically, or Medlar? I'm trying to get kind of a picture of what type of customers.
Sure. Excellent question. And so medium-sized enterprise, also some small enterprise, MSP, as well as some large enterprise. So it really is, it does kind of spread pretty broadly, because even large enterprises, I mean, I need to be careful who I mention specifically, but we have large carriers that use us because they figure this is the only way to look at all of those error counters on all of the interfaces. And it gives them the ability to say, are we dropping packets anywhere between point A and point B? And because we're looking at every error counter, we're going to be able to say, no, you are not dropping any packets by any error counter between any of the involved links between A and B, no matter how big or small the network is. So we have small companies that say, gee, we've got 250 users, and they want something that's automated, that deploys and says, here's what's broken in your network so you can start fixing it right away. But also very large enterprises, MSPs, and carriers that say, we need to do rapid troubleshooting as well. Also, MSPs that come into a customer and say, I need to know this network quickly because this customer has problems and we can look like a genius if we can solve this problem faster than the other company.
Now, where I saw that you differentiated yourself is you have a focus on layer one, which most companies don't have any focus on layer one. And it actually took me back to the troubleshooting class for my Novell CNE, which, back in the day.
Awesome.
I thought that was kind of a differentiator for your product. Do you sell through channel partners, or what's your go-to-market?
So we do sell a lot direct. We do sell through channel if it's required by the customer. So yes, both. As you mentioned, layer one, we are strong in layer one because we can identify those cabling issues, but we're also incredibly strong in layer two, layer three, and some layer four by the fact that we're measuring the QoS. In one sense, if you're looking for application layer, there's a lot of solutions out there that focus on really layer 7, and that's not our strength. So I'll be fair and say this is where we are stronger than anyone. And if you're looking for application specific, there are other solutions out there. So I figure know what we do and know what we do better than anyone else. And also, I'm free to say this is what we don't do.
So following up on Rita's question, you mentioned in the diagram, put a single server and get this. I'm not sure if that was a figurative single server or a literal single server. because on the scalability front, obviously we've talked from small businesses, small enterprise through to large enterprise and carriers. Single server seems like maybe could be a scalability issue. And also, I guess related to that also comes back to how often you're pulling that data, right? Because the reporting was like, oh, from this minute to this minute, you were seeing packet loss on a link. So I'm curious how often you're getting that data back from the potentially hundreds, thousands of devices. So what is your scalability for this solution, and how often are you pulling the data? And I guess how configurable is that?
Yeah. So by default, we poll every 5 minutes, and that tends to be granular enough where people will say, I just need to know what's going on roughly every 5-minute period. If they want to, they can dial that back and say a 10-minute period is still reasonable. You're not missing visibility inside that 10-minute period, because I think we all know that the SNMP counters are all like odometers. So you don't miss any data. It's a question of how granular do you want it. So 5 minutes, 10 minutes, really up to the user. The mechanism for collecting that data is designed really by network engineers. And the reason that we designed it by network engineers and not by programmers is that a programmer would just send a flurry of SNMP packets out to collect the data without any thoughts. We end up doing it where we're collecting 28 different OIDs with a single packet. What that means is we can collect far more information on larger networks with less chatty packets flowing all over the place and have far better scalability than any other solution. So we can actually scale up to 200,000 interfaces. So if you have a network that has 200,000 interfaces, we can do that on a single server. So the scalability is rather incredible by the fact that we've designed it to work very efficiently with our network footprint. Let's say you have a 48-port switch at the far end of a WAN link. That means every 5 minutes we're sending 48 packets and we're receiving 48 packets. Generally, that's kind of a spit in the lake. On the server side, regarding scalability, we can support a single virtual machine, and that single virtual machine has its database built in, and the database we use is called SQLite. And if you're familiar with SQLite, it is a C-compiled database that is compiled directly into the application specifically for performance reasons. What we found is early on in our company, we evaluated this and realized if you use some separate database, what you're doing is you're creating performance problems by the fact that you now have a network interconnect that you have to deal with, where in our case, we're able to write that data directly to the disk with caching. And so we can scale up far better on a single machine with this database that's compiled directly in, again, as a C or C++ application. So on a virtual machine, we can go to 150,000 interfaces, and that 150,000 interfaces is a 4-core machine with 16 gigs of RAM, and typically you'd probably want to give us about 50 gigs of disk space. So that caliber of machine is pretty readily available on a network of that size, and so it's not going to drown your budget with a lot of other solutions that require you to say, gee, you've got to set up this massive database, you need 12 collector servers that all have to be updated, and there's care and feeding required. That was something that frustrated me, is that nobody considers network operations in their deployment. They just figure, oh, deploy all these servers out there, tie them all together, and eventually you'll have the data. We figure, no, make a single solution incredibly scalable so that you have less care and feeding, less servers you have to deal with, less licensing, and less virtual machines that cost your company money.
So wait a minute. This whole thing is an analytics engine that scales up really big and isn't an entire rack worth of equipment?
That is correct.
I'm liking it.
And presumably there's a tie-in from presumably this needs an administrative type service account within the AD domain as well, to be able to figure out processes on who's on a machine and on domain machines.
Yep. And you can tighten that down. It doesn't have to be an admin equivalent account. You can tighten that as appropriate or as desired.
Tim, earlier you mentioned being able to pull processes from machines. Was that from the servers, the domain controllers, or was that from users' machines, client machines?
Both. So effectively, in managing the servers, you want to be able to say what's running on the server, what's running on the client. I'll get into some of this when I get into the demo, and I'm wondering if this might be the right time to shift into the demo. If you guys still have some more questions, I'm fine doing that. But
maybe, yeah, let's jump into the demo. But I was just wondering, how are you pulling process information if you don't have an agent on an endpoint?
So the information is available through WMI if you have the proper calls that you're using. So again, it's if we invest the right time and ability to build it the right way, you don't need agents. And that's, again, part of our mantra is that people just don't like deploying agents. It's a pain. And so if you can do it without agents by doing it the right way, the clever way, you'll solve more problems at the end of the day.
So Tim, how are cabling issues detected? Are you using the SNMP counters on the interfaces or in any other way?
Yes, so we're using the SNMP counters. So a lot of switches have incredible smarts built into the switches. The problem is that most people don't know how or what to query off of the switches to determine what is it trying to tell you. I mean, if I spit out 1,000 SNMP OIDs in front of people, you'd troll through that and say, well, okay, there's nothing here that says specifically there's a cabling fault. But if you did proper interpretation, you'd be able to say, when you have FCS errors on an interface and you have symbol errors on an interface, but you have no alignment errors or collisions or other error counters, you should suspect that there's a cabling issue going on, because that's how the error counters combine to say this is a problem at layer 1. So it's based upon the fact that we have a lot of smart engineers here that have said, gee, we have experience with this stuff. Let's bake this into the solution so that you can find this stuff.
Okay, and you mentioned that you are polling like 48 or 96 port switches. Are these polling split across the 5 minutes so you don't overload the CPU of the machine?
Exactly. You got it. So instead of sending a flurry, again, we can request 48 packets from the machine saying, get us all 48 of these interfaces on this device. If we requested them at the same moment, yeah, that might cause a CPU spike. What we do is what's called a slow poll. We have a 5-minute window talking to that device. So we can say, go get us information on interface number 1, and we wait. Now go get us information on interface 2, and then we wait. And so by doing that in a paced fashion, we won't cause any CPU spikes. We're not going to cause bandwidth spikes at the beginning of our polling. And we end up making it so that we're getting far more data than any other solution, yet we're getting it at a slow, proper pace so that we can still get it without disturbing anything. Very smart question.
Okay, another question about the discovery. You do automatic discovery of the network.
Yes.
Is it only via SNMP, or do you use also routing protocols, CDP, LLDP, and
so we do the discovery via SNMP, and so we'll end up walking the network and look at the subnets that you've given us, so that you can say these are the subnets I want or I'm responsible for, and it will walk those subnets, find the devices, and automatically add them to monitoring, so that by minute 13 we're going to start telling you, hey, did you realize you've got a VLAN tagging problem on interface 8? Did you realize that your trunk port is misconfigured and you're dropping 7% of the packets? These sorts of things start happening very rapidly after deployment, so that you can start improving the quality of your network. And really, our big trick is a lot of folks are stuck running networks that they just don't know enough about what's going on. And so they're caught unaware. We never want to be caught unaware. And so we built the type of solution that can make sure that you know what your network switches and routers already know. So all of that intelligence that's stuck up inside your switches and routers comes back, and you're able to say, oh, I now know that we have packet loss on this switch. I now know that we have a missing default route on this router, or we have an incorrect subnet mask set up on this server. So with that knowledge, you're going to be able to say, I'm going to spend 10 minutes solving this problem, 20 minutes over here, 30 minutes over here. And you spend a couple of hours and you find out that I've just fixed all of the major problems in this network because I know what the network knows.